And today my presentation topic is Pivotal role of GPUs in AI and deep learning accelerations. The AI revolutions powered by GPUs. How graphical process unit is become an engine of modern AI artificial intelligence. The computational challenge. Why AI needs special hardware? Because neural networks million to billion of parameters require to immune computational resource. Massive datasets. Training models involve the processing terabytes by deserved by data efficiently. The real-time requirements, applications like automations, vehicles, and voice assistant demands instance processing. Traditional GPUs too slow and sequential for a scale parallelization of modern AI workloads. Consider this: training a GPT-3 would be take 355 years a single CPU compared to just 34 days only in GPU clusters. Pretty faster GPU. CPU versus GPU architecture is fundamental design differences. CPU central process unit, few powerful cores, typically 2 to 64, sequential tasks, optimization complex step-by-step operations, complex control logics, managed device, computation, computing needs, general purpose, wide range of applications only. GPU graphical process unit, thousands of cores, typically 2000 to 10,000 smaller cores. Parallel processing designed for simulation relative computations. Simple operations, efficient and massive data throughputs. Specialized workloads, ideal a graphical rendering in AI. Analogy: if CPU is a sport car for precision tasks, a GPU is a massive transmit system of move most of the data of simulations. The perfect match. Why GPUs accelerate the deep learning. Neural networks are inherent parallel metric multiplications. Both are neural network computations, conversations, operations, fundamentals in image processing, CNNs, activation functions applied across of numerous nodes simultaneously, key instant, the sum architecture that effectively rendered the millions of pixels in parallel for the gaming and graphical efficiency processing neural network layered by parallel dramatically acceleration of AI computations. GPU architecture for AI specializations and hardware components. For example, NVIDIA A100 GPU is 600 912 core cores, general process parallel processing unit for the diverse computational tasks, 432 tensor cores dedicated to AI accelerators, optimization for mixed precise matrix operations, crucial to deep learning, 40 GB HBM2 memory means high bandwidth memory ensure rapid data feeding to processing unit. 2 TB memory bandwidth is faculties of incredibly fast data access to and transfer muting of the bottlenecks. Tensor cores Tensor courses are the game changers, especially the engineers are accelerated fundamental metrics, computational and data underpin deep learning algorithms. Performance comparison of real world spaces, speed and differences. C- GPU provides significant speedups across various of AI tasks, making a practical AI development and face level tasks like image classifications, ResNet 50, large language model training, medical analyze and speed recognize. There are some comparison between GPU timing and CPU. Same tasking taking time 100 time 100 ms and GPU timing is 5 ms, speed up 20x. Large language model we trained in 2 weeks in GPU timing, CPU timing. In GPU we can in 1 day 14x speed ups. Medical image analysis 40 minutes in CPU. In GPU 90 seconds only 30x speed ups. Speech recognitions 300 ms in CPU, 15 ms in GPU, 20x speed up. AI workflows accelerations, trainings versus interfaces. There are the flow is neural network flow. There are predictions. Y is yellow is predictions, and true values perfect values. The loss functions is called loss. If information is wrong, then loss function true. There are data converting. The predictions are convert their informations. Training phase involves the forward and backend progressions, gradient calculation, and weight update across the millions of parameters. GPUs reduce the training time and from weeks to hours, unable to rapid iterations and development of complex models. Infrastructure phases focus on the real timing predictions on batch processing. GPU enable to real-time AI application essentials for the immediate responses to critical systems. Software ecosystem is a complete AI stack. NVIDIA ecosystem is COUD is NVIDIA Parallel Computing Platform. Foundational of GPU programming is CUDNN high optimized library for deep neural network accelerations core operations. TensorRT, a programmable interface, is acceleration high performance deep learning interfaces. Framework supports is seamless integrations with a proper framework like a TensorFlow, PyTorch, and MXNet. Some workflow on Python. Open alternatives. ROCAMs, AMD, open source platforms, GPU computing, OpenCL and Open Standard Parallel Programming, Hierarchical Systems, Open API, Intel Uniform Programming Model to design architectures. Real world applications like GPU acceleration, AI actions, like healthcare, advanced medical images analyze, MRI, CT scans, accelerated drug discovery, and protein flow fluid simulations, real time surgical assistance, and diagonal automation vehicles, precise object detection and classification for safe navigation, complex path planning and decision making for dynamic environment, effective scenario functions, processing from multiple inputs, natural language processing, instantaneous real timing, translation and transcriptions, sophisticated voice assistants and chatbots, advanced content generations and summarizations tool. Thank you for to listening me. This is today presentation top completed.